Okay, so let's now jump into the technical content. So why Java? Someone asked why not C++? Because it's the straightforward skill extension to what we covered, right? And the main reason for Java is we want to cover what we focus on this course. You guys talk to each other because you have questions? You should ask me, right? We cover Java for a completely different reason. It's not about the syntax, right? It's about, actually, Java syntax is very similar to C and C++, right? But it's about the methodology, right? The philosophy of the language itself. We covered C, and we had its use cases for embedded systems. You need fine-grained control over what you write. You have access to the memory. You have pointers. It's a low-level language, right? But Java, as we will see now, has a completely different mindset. It's a more of an object-oriented programming language, and we will see what is object-oriented programming. So the concepts we cover in Java are different concepts, right? Like just the mindset is different from C. This applies to any other language. You can, like now we have so many OOP languages, like you can write even interpreted ones like Python. But you can have classes in any other language, but once you know the mindset, you can apply this to any language. By taking C and Java, then you combine the benefits of both worlds. The world of fine-grained control of the hardware. You care about memory allocation, you care about pointers, and you have very limited object-oriented programming. So this is the disadvantage of C. And by covering Java, we take this advantage. You have an object-oriented programming language. Once you learn those concepts, you can apply them to anything, including C++ or Python or any other language. Good? So, and this is something that I want to mention before even we start in Java. What is the mindset of Java? Why it's different than C? Good? Again, this is not just about writing code or syntax, it's about you understand what's going on, why people have different languages. Good? So Java was originally created in Sun Microsystems. Now Sun is part of Oracle, but Sun one time was a very big hardware software company, and actually the idea of Java is a very neat idea, as we will see right now. It's released in '95, so it's compared to C, it's a very young language. Compared to other languages, like mature. And it's one of the most popular programming languages for different reasons. One of them, it's very modular, it's fully supporting OOP, and one big advantage in Java, you can call it machine independent, and we'll see now what does that mean. Okay? Good. But what does Java even mean? What is, like, C is just a letter, so it doesn't have a meaning. But Java, what is Java? Does someone know? Yeah? Coffee, yeah. And why it's called Java? Yeah, so how coffee is related to, and if someone know like the symbol of Java, like the logo of Java, it's actually have like this coffee cup, right? So originally they actually called it Oak, but there was already programming language with the same name. They had to come up with a different name. But they were actually meeting in a local coffee shop nearby the company to come up with the finals of the project. And they say, let's just call it Java for this reason. And this is the symbol of Java, like it's a coffee thing. Okay? This is like a fun part of why it's called Java. Why Java, right? As I said, it's a fully object-oriented language, and it's robust. And the main important thing in Java, why it's very common right now in almost all machines, it's very portable. The reason, it's partially machine independent. So you can run Java in your Apple laptop, in your Windows and Linux, and it's the same program. You can also run C in all these machines, right? But what is the difference? In C, you have to recompile your source code from the beginning to come up with a new executable. The executable that is running on Mac OS does not run in Windows, and it does not run in Linux, and it does not run in Solaris Sun operating system. It does not run in an embedded system that is in Android, for example, right? So you have to each time recompile your source code to get a new executable for the operating system and the hardware. Right? In Java, it's a bit different, as we'll see right now. Right. And for the syntax thing, so this will allow us to go faster. The syntax is very similar to C. So the concepts we covered in C will also apply in Java. Like arrays is like very similar syntax, variables is the same thing. There are some differences here and there, but in general the syntax is very, very similar. Good? So this will help you like kind of catch up easily with the language and will go faster in lectures. Why Java is highly portable? Right? So I said it's machine independent, or you can port the language to any machine. Why it's highly portable? Because it's, forget about like what I write here right now. I just want to jump to, I'll come into this later. So you remember this slide? This was our second lecture in C, and we said the way C works is you have to go through all these steps. From the source code, you do a pre-processing, compiling, assembling, linking, loading, right? This was our second lecture, and we explained all of this in details. If we look into this, starting from here, after the pre-processing, which is you still have your source C code, compiler, assembler, linker, loader, all of this is machine dependent. Because remember we mentioned assembly code. What is assembly code? You are writing something in the ISA, the instruction set architecture of a certain hardware. The machine code that is created for Intel x86 is completely different than the machine code that is created for ARM version 8 or version 9. The instructions themselves are different. Like add is written a different way, sub is like, remember we had this example of add, sub, multiply instructions, like the instructions on the hardware. It's called assembly language. And I guess you will cover this in one of the digital design courses for CompBench. Those are different from hardware to hardware. And that means all these steps are completely different, and you have to recreate them from the beginning for every hardware and for every operating system. Good? This is how C works. The philosophy of Java is completely different. How? Have your program, you go through a compilation stage, but then the output of the compilation stage is machine independent. Like the output here can run in any hardware. How they were able to do this, and this is the nice idea about Java. And I tell you why, originally what was the need for that in 90s, right? They needed to do something that you have a source code, you need to be able to create a program that runs in any hardware or operating system. Good? This seems to be kind of a very cool idea, right? It will make the language very portable. You just take the same program, assume you are a software engineer, you write a program, and then you give it to anyone. He will be able to run on his own machine. But how can I do this? They do this through an extra step that they call interpreter. What is created here is something that is called Java bytecodes. Java bytecodes is you can think of this as their own language, right? Their own instructions. What needs to be different from hardware to hardware is the instruction set, right? Like add, sub, multiply, these instructions. These have to be different from Intel to ARM, as I mentioned, right? What if we can have a more abstract intermediate language between the source code and these instructions? Something of our own, like Java. You can think of this as Java micro instructions, right? And this is what we call bytecodes. The compiler generates these bytecodes. But at the end, I need to run this on my machine, right? So they provide you with the environment that you can run in your laptop as if you are emulating their own Java machine. And this is why we call Java virtual machine. I guess any laptop among these are open right now already have JVM running, right? I don't expect any laptop that doesn't have JVM installed, because many applications will depend on that, right? So what is Java virtual machine? It's the emulation environment that takes the bytecodes and run them in the hardware, right? So they build this abstract layer between the Java programs and the hardware. Right? So they take the bytecodes as an input and generate the assembly and then the binary machine code to run in your laptop. By this way, the program itself is independent. As a software engineer, I write a program, it's completely independent of the hardware. And what is dependent on the hardware is the Java virtual machine itself. The JVM, that is, if you go to the Oracle website, you download JVM for Linux or Windows or Mac OS. These are different software, right? Like the JVM itself is different, so it's machine dependent. But the code you write to run on JVM is machine independent, and this is the cool thing, right? So what is JVM here in this picture is the interpreter, basically. Okay? So now we go through two stages. First of all, the compilation. You have your Java source code program that you write, which is file name.java. And then you run this through a Java compiler. It gives you what we call a bytecode, Java bytecode. Good? Now, you need to take the Java bytecode and run it through the interpreter, which is the JVM. And it gives you the machine-dependent, whether it's Unix, Linux, Windows, Apple, anything else. Good? This seems to be a very cool idea. And in 90s, they thought in this, the team that thought in this in Sun. Right now, it's a common thing, which is like the intelligent devices, the IoT devices, right? You have like a smart fridge, a smart stove, something of that sort. They started thinking this in 90s, and they said, now we need programs to run in completely different environments. How can we do this? Should we rewrite every single program? You write a program for your fridge, and then you write a program to another, like running a smart car, and then a program that is running for a smart factory. You have so many other things or so many targets for your program. So if you create the program from the beginning or compile it from the beginning for all these destinations, it will take time and it's not user-friendly. So they came up with this language originally for this reason, right? IoT and smart appliances or smart devices didn't like catch up until maybe now, like after 20 years. But Java became very common because it had so many other applications. You can run Java programs in even your browser, in your Chrome. Many of the Chrome things, you can actually run Java program on the, which we call applets. You can run it on the browser itself. You don't need even like an operating system. Good? Is there any question in that? Yeah. Good. That's an excellent question. So if I need a Java virtual machine for every target, like for Apple that is different than Linux that is different than Windows, then what is the difference? Maybe I just take my program and compile it in C for this and this and this. It seems to be the same steps. The difference is you only get the virtual machine once in your hardware, right? You just install JVM once in your laptop. And you will be able to run any Java source code. So you don't need to recompile. Assume I wrote a program in my Linux machine in Java, and I gave it to you, and you already have JVM installed. You don't need to do anything. You'll be able to run it directly, right? On the other hand, even if you have a C compiler in your machine, and I have a C compiler machine, I wrote a C code, I give you my executable, it doesn't run, right? The reason it doesn't run is you need to recompile it in your own machine, right? So as you can see, you need to do something extra for each program in C. But in Java, it's not the case. You just get the Java virtual machine once, it's done. You run any Java code, whether the creator created it in a different operating system, the same operating system, different hardware, the same hardware, it doesn't really matter, right? This is the main thing that is Java is different than C. It's highly portable. Good? Is there another question? Okay. So I keep saying JVM, JVM. What's JVM? And this is maybe outside the course, but something that maybe if you hear these terms, it's good to know what are these, right? JVM is, as I said, you can think of this as the interpreter, the environment, the abstract environment that the bytecodes run on, right? We also have the term JRE, Java Runtime Environment. How JRE is different than JVM? JRE is nothing other than JVM with some other things, some extra libraries that you can use, you can link with when running a certain program. So it has some other libraries and some other files. And then JDK is a complete thing. By only having JRE, and from the Oracle website, you'll be able to install only JRE or the complete JDK. JRE is okay if you only want to run programs of Java. But to develop programs of Java, and you need some support, some development tools, when you are writing your programs, maybe you need to install the JDK, which has the JRE and some other development tools like the compiler and the interpreter. Good? So as a programmer in Java, what I need to give to someone to be able to run my code, I need to give him my binary or my bytecode, my Java bytecode. And then he will take this, run it in his own JVM, and this will run regardless of what is the target machine. Good? Okay. So let's jump into one example. This is like theoretical information. Maybe it's good to see a Java program, right? Looking into the Java program, it's very similar to what we started writing in C, the hello world example, but the syntax is a bit different. And what is different? What is the difference here? The first thing that you encounter that we didn't have in C is you have to start with defining a class, right? In C, we just had void main or int main, and we wrote our own program, right? Then you name your file anything. And we know now from C that main is a function, right? But function is not enclosed in anything. It's just a main function is standalone. You don't need to define class, or even in C you cannot define class, right? In Java, everything has to be included in a class. So you cannot run any Java, or you cannot write any Java function, or in Java terms, Java method outside a class. So the entity in Java is classes, right? And this is the object-oriented. The more we move into Java, we'll see that this is the OOB methodology, is you think of every single file or a program as a class, and then later we will connect different classes together. So we start by defining a class that we call my first application. You can call the class anything, like a valid name. You should start with a letter, then it can has anything. But a good programming skill, a good convention between programmers is classes have to start with a capital letter, right? So you start your class with capital letter. But if you didn't do this, the compiler will not complain. But again, it's a programming convention. If you give your code with a class name that is like a small letter, a good programmer will know that you are not a very good programmer. You are still kind of a beginner in Java. And then after defining our class, we include our main function inside this class. Void, we already know void because it returns nothing. We already had static before, but the thing that you need to know right now is the main function. In C, we can only have one main in a program, right? In Java, it's the same thing. You cannot have more than one main function in a class. The reason is, what is the reason from C? Why I cannot have two main functions on the same program in C? Yeah, exactly. Please give me your name afterwards. So the thing is, as a compiler, when I'm starting running your code, where should I start? The start point, the contract between me and the compiler is you should start from the line of the main header. So as a compiler, this is my starting point. And when you debug your code, you can add like debugging tools in Xcode or CodeBlocks or whatever tool you are using. If you start debugging your code, you'll find the very first letter that the compiler is starting from is the main function, right? If I have multiple mains, then I don't know where to start, right? This is why it doesn't work. The same thing for Java. You can have only one main function in a class. Good? And then it has to be public static void. Later we will see why, right? But for now, public, because this is the start point of your program, you have to have access to it. So it has to be public, right? And then void, because it returns nothing. And then static, you guys know that static is the resistance of this function or this method in the memory, right? Good. What do I do here? Let's forget about this right now. We'll come into it later. But then this line, right? This line is the same line as, maybe it's a very big line, but in C it was just printf hello world, right? You had the printf function. This is exactly the printf thing. But because Java is modular and everything is based on classes, you cannot just write printf. You have to first mention the class that includes the printf, and then what is, even if there is like a child class of that, and then you go to printf. So you have to go this step by step. Everything is modular, as if you have different buildings, right? And then printf is just one room inside one building of these. You have to go step by step. So what we do here is we access the system class, which is one of the already existing classes in Java library, and then .out, because print line is a method that is implemented inside this out thing. You are trying to out something in the screen, and then print ln is print line. We actually have printf as well, right? But let's for now say print line, And then you print this line. Good? So this is the general syntax of this thing. The last thing is, what do we have here? Maybe we didn't need this in C, but you can do the same thing in C. We used that main function doesn't take any inputs, right? But I guess in one of the lectures I told you, you can actually pass arguments to the main. How to get, and this is one of the ways you can make your code modular, right? If you run some programs, they can take some inputs from the terminal if you are using Linux, or from the tool if you are using like a GUI. But the thing is, I can input something to the main, and these are stored in an array called arguments. So I can run a program, say for example, my first application, and then integer 1, integer 2. Then you input two things to this integer, right? So this is also a valid syntax in C, but this makes your program expecting from the beginning some input parameters from the user. Good? We didn't need this now, but this is the template syntax of the main function in Java. Is there any question? Yeah. Yeah, so we will come into input arguments later at the end of this lecture, but what you do is you read the parameters from the user one by one, and each one of them is a string. What if I want to input an integer? We will see how to do this now. But every single parameter that you input to the user is a string, because you write it in the screen. Good? How to deal with this and why this is an array? Because you can input one thing, two things, three things, 100 things, right? As a user. And this allows you to, as a program, you can say args0, which means the first parameter, args1, the second parameter, and we will see arrays right now. Okay. Okay. This is all explaining what we have. Yeah, I mentioned that we already have printf. You also have .print, right? But print line, what it does, it gives you, it outputs this thing, and then it moves to a new line. So if you also print another line here, it will print in another line. You just, in C, you can do this, but by either using endl at the end of cout, or printf, or you can just put the regex/n as a new line. Right? So you have to do it yourself. As you will see also, in Java there are many things that you shouldn't be doing on your own. You have the support for that. Right? Okay, so let's have another example here that I want to add two integers. So how can I do this? I name my class something. Here I call it add integers, and then the same syntax for the main. I need to read, you remember our very first quiz was to read something from the user as an input, right? So here you can also, in C we use scanf, right? Here we use something different that we call scanner. In Java there is an already existing scanner class that scans the screen to read an input. So the way to do this is you define, first of all, you need to import the class itself. So you import java.util, because scanner is a class that is part of the utilities library. Java.util.scanner, and then you define a variable of this scanner thing. Scanner input equal new scanner something. Yeah? What does it do? Input here is a variable or an instance of this class. So it's a scanner class. And then it defines a new class, scanner, and this new scanner should be from the screen, so it's system.n. Right? And then if you are confused with this one right now, just forget about it. Let's continue. I'm just defining integers completely the same way that we defined before, int num1, num2, and then the sum. And then we have seen this before, system.out print line. You ask the user to input something. And now comes the need for this one. I need to read the first integer, right? How to do this? I read it and then put it in the num1 variable. The way to read it, given you already defined input as a scanner class, input has a method that is called nextInt. NextInt is a method. When I say a method in Java, it's a function in C, right? It's just the word is different, but it's completely the same thing. Method, like the scanner class, has a method called nextInt that reads an integer from the screen. So you can think of this as if it's scanf, like this %d reading something, right? And then it reads the first integer and put it into the num1 variable. And then I do the same thing for num2, the other int. And then now I can do the sum and then print the sum on the screen. Here you see that I use printf similar to the C syntax, which I told you you can do in Java as well. And printf also is part of the out class. Okay? Is there any question here? Yeah. ln, yeah, it's print new line. So what it does is it prints this thing as a complete line. Here, what we have done here, at the end, you added the new line specifier in the printf statement, which means you print the sum and then you move to another line. If you print something here, it will be in another line. But if you didn't do this, anything you print afterwards, it will be on the same line as the sum, right? Print ln does exactly the same thing for you. It prints this thing and moves to another line by default. Just print in a line. That's it. It's a print line, right? Is there any other question? Something you can do is you guys, if you don't have NetBeans installed in your laptops, we have the online GDB compiler that we use. It also supports Java. You just need to select the Java language. And then I'll give you 2 minutes to try to write this thing. Try just to see, this is your very first Java program for those who doesn't know Java. And then you start writing your first Java application to have a sense of what is going on. Okay? You have 2 minutes for them. You guys done? Okay. So we explained that. Here, some of the differences in Java is you have by default, and again you will see this, Java is actually an easier, maybe, this is not the right term, but we can say it in this way, it's a casual term. Java is easier to program than C. The reason is, in C, you have fine-grained control, so you have to take every single thing. In Java, it already have very established methods, classes for you, and then the support is larger, right? And then you don't have this fine-grained control, but at the same time, it's easier to program in. Right? And if you are looking for maybe a much easier language to program in, Python is the example here. Right? Python is very easy to program in, but you don't have any support. It's a very highly abstracted language. And we discussed this trade-off before. Fine-grained control versus hard programmability. Good. So in Java, based on this easier to program thing, based on this support, you have many types of things. For example, in integers, if you just write byte, you have different types of integers based on what you want to do. If you want to define an 8-bit integer, then you just use byte. If you want 16-bit integer, then it's short. Int is the default one, 32-bit. Long is 64 bits. Short, int, long, we already had these from C. Good. In real numbers, you also have float and double, similar to C. This is single precision floating point. This is double precision floating point. In character, it's different here. You remember we said we have this problem in C where characters are ASCII code, right? Characters are only 1 byte, 8 bits. And we said this doesn't work for some of the languages that exist, right? It's mainly, the ASCII code is mainly for English that has only 26 letters, and then it's enough to have 2 to the power 8 minus 1, which is like 455 characters to put all the symbols in a keyboard. If you have something that is more than this, like a Chinese language, for example, it doesn't work. And then we said some of the other codes is the ISO Unicode, which has 16-bit. Java, by default, a character is 16-bit. Okay? And then we also have